Math 193 11E in-class activity. Circular motion. An amusement park has two Ferris wheels that are located side by side. The Ferris wheels are the same size. So if Jimin and Neela each began riding a different Ferris wheel at the same time, and the wheels turned at the same speed, their gondolas would remain at the same height as each other for the entire ride. Assume, however, that one wheel rotates twice as fast as the other, and each ride lasts 2 pi minutes. Jimin's rides on this slower Ferris wheel completes only one revolution in this time, while Neela's ride on the faster wheel completes 2 revolutions. Between 0 and 2 pi minutes, how many times might Jimin and Neela be right next to each other? Think about this question, pause the video, make an attempt, and let's discuss it together. Now, in an attempt to answer this question, let's look at this as Jimin and Neela's Ferris wheels. It will be very difficult for us to be able to determine at which time they will be next to each other without some calculations. But what we can say is that at the beginning, if Jimin is here, then Neela is going to be there. And we know that Neela goes twice as fast as Jimin. So by the time he goes 2 times and comes back, Neemon would have also gone only once and be back at the same place. And so our simple answer is going to be that Jimin and Neela will be right next to each other at the start. At the start, they are here, and end of the ride. When this goes once round the circle and comes back, this person would have gone twice and come back to the same place. And so this is going to be our sample answer. Objectives for the activity. In this activity, you will understand that the double angle formulas can aid in solving trigonometric equations. And you will be able to solve a trigonometric equation by obtaining common arguments for all trigonometric functions. Now, we can model the situation that we just completed. We can model Jimin's and Neela's positions with the equations below, where T is time measured in minutes, X is the ground position of the passenger, and Y is the height of the passenger above the ground measured in meters. The passengers start their ride when T is equal to 0 and end their ride when T is equal to 2 pi. Subscripts D and N will be used to identify the positions for Jimin and Neela. Now, let's assume that this is for Jimin and that one is for Neela. We know Neela rides twice as fast as Jimin. So if we represent here by T, then that place is going to be 2T. Now, let X be the horizontal position for that. Then we know that sine T is equal to the opposite, which is X now, over the hypotenuse, which is 10. That is the radius. And so our X becomes 10 sine T. Now, by similar reasoning, we are going to get for Jimin, for Neela, X. So let's call this xd for Jimon, as we can see at the top here, to be equal to 10 sine t, and then Sn for Nila is going to give us 10 sine 2t as that is the horizontal position. Now let's assume this is a vertical position above the ground. It is the same as this distance. Now that whole distance is 10. That is the radius of the Ferris wheel. That whole distance is 10. Now we want to find this vertical distance above ground. So it is going to be this whole distance minus that small distance yd here. And from the diagram, you will see that the cosine of t is equal to the adjacent, which is yd, over the hypotenuse, which is 10. And so yd becomes 10 cos t. But then we want to get this vertical distance above the ground. So it becomes 10 minus 10 cos t minus this whole distance minus yd. So yd becomes 10 minus 10 cos t. This distance, becomes 10 minus that distance, and that distance is 10 cos t. And we do the same for Nila's motion. Now let's answer these questions. Before trying to determine when Dylan and Nila are side by side, we will check the reasonableness of the above equations. At what height do Jimon and Nila begin their ride? Based on these equations, what is the diameter of the Ferris wheel? Which direction is the wheel turning if the passenger locations are in the usual XY plane? How do you know? I want you to pause this video, think about the questions, make an attempt, and let's discuss your attempts together. Now let's look at some answers. We want to find at what time Jimon and Nila begin their ride. Now, if we use the vertical distance for Jimon, which is 10 minus 10 cos t, then at time t equals 0, we'll see that yd is equal to 0 for Jimon. And by similar reasoning, when t equals to 0, 10 minus 10 cos 2t also becomes 0. So they begin at the ground level. Now the second part we want to look at is we want to find the diameter of the Ferris wheel. We know that the amplitude is 10. And so from here, we are getting 10, the highest point. And so it means that this is going to be twice the 10, giving us the diameter to be equal to 20 meters. Now, which direction is the wheel turning if the passenger locations are in the usual XY plane? How do you know? Now, as t increases, as at time t equals 0, as t increases, the cosine decreases. As t increases, the cosine, which indicates that y also does what? Increases. Also, as t increases, the sine increases, which indicates that x also increases. Now, if we have something like this, and this x direction is given by xd is equal to maybe 10 cos t. Now, you will see that when t is 0, cos 0 is going to give us 0, and this is going to 0. As t increases from 0 to a certain point, xd increases. And so as it increases to maybe pi on 2, you see that sine 90 is 1, and xd, we get our maximum point 10. So as t increases, you will see that the sine increases, and then the cosine decreases. And so this fact tells us that the passengers start from the bottom and move up and it is going in the anti-clockwise direction. We will now determine when Jimon and Nina will be side by side. Part A. If Jimon and Nila are side by side at some point during their ride, their respective x-coordinates must be equal. What equation must be solved so that their x-coordinates are the same? Part B. This equation may be difficult to solve since the arguments of all of the trigonometric functions are not the same. Use the double angle formula to write this equation with the same argument in all trigonometric functions. Part C. For 0 less than t, t is less or equal to 2 pi. Determine when Jimon and Nila have the same x-coordinate. Show your work. I want you to pause this video, think about the questions, make an attempt, and let's discuss your solution together. Now, in solving this, all we want to do is that we want to equate the x component. And so we're going to equate xt to be equal to xn. And xt is 10 sine t, and xn is 10 sine 2t. Part B. We want to use the double angle formula to solve this equation because this and that, they don't have the same argument. This is 2t and that is t. And we know that sine 2t is equal to 2 sine t cos t. So instead of writing sine 2t, we write that 2 sine t cos t. And remember there's a 10 there. So we just bring the 10 and this is what we are going to get. We can simplify this further and solve for this equation. So we get t to be equal to 0 or cos t is equal to 1/2. Now t equals 0, sine t is equal to 0 is true when t is equal to 0 or when t is equal to pi for sine t and when t is equal to 2 pi. And then also cos t will be equal to 1/2 when t is equal to pi on 3 or t is equal to 5 pi on 3. So these are the solutions for these equations. Now, determine the times at which Jimon and Nila are at the same height. Show your work. When are the times t with 0 less or equal to t and t is less or equal to 2 pi? When Jimon and Nila are side by side. I want you to think about these questions, profess some solutions, and then we will meet to discuss your solutions after you've paused the video and looked at it. Now let's solve this equation. This time we are going to use the vertical positions yd is equal to yn to solve our equations. And so you remember that yd was 10 minus 10 cos t and yn was 10 minus 10 cos 2t. And cos 2t, if you remember, this is the same as 2 cos squared t minus 1. And so we rewrite this as 2 cos squared t minus 1. And there's a 10 outside, so we do that and we simplify this. And we are going to factorize this expression and get cos t equals 1 or cos t equals minus 1/2, which gives us for cos t equals 1 when t is equal to 0 or t equals 2 pi. And cos t is equal to minus 1/2 when t is equal to 2 pi on 3 or 4 pi on 3. Now the last question is when are the times t with 0 less or equal to t 2 pi when Jimon and Nila are side by side. Now this happens only at the point when both the x-coordinate and the y-coordinates are both equal, and these are at time t equals 0 and t equals 2 pi. Therefore, during that trip, the faster wheel, that is the wheel that goes 2 times faster, catches up but never passes the slower wheel. Thank you for watching this video.